All right, welcome everybody to Sustainable Design Masterclass. I'm Neil Spagman, and on the left of your screen is Raleigh Latham. We're the co-founders of this webinar series. And we've been doing this for just over 2 years now. We bring the world's top experts in fields related to sustainability. We've had a really good run on water, and we are going to keep going through March, I believe, on this water series. If you want to check out previous webinars, go to sustainabledesignmasterclass.com. We've got around 45 webinars with some really amazing folks. Really good content. And we are really pleased to have you here today. And before we really get going, please turn off all of your distractions, your cell phones, your other programs, your email, your Facebook, all those social media platforms, because we've got some really interesting stuff coming up that's crucial in, if you like water, if you need to drink it, then this is important stuff.
Oh yeah. Well, it's going to go far beyond drinking water, but I have to say I am extremely excited to bring Vlado, Mikhail, Jan, and the translator Jana onto this, because this plan they're going to introduce, Rain for Climate, and the new water paradigm is the most important thing I think I've ever read in my life. You're not hearing about it in any science class, any biology classes, and yet it has the potential to have the greatest impact on climate out of any plan out there. What you're about to learn will flip your understanding of climate on its head. If you listen to our webinar with Walter Jen and Judah Schwartz, you got an intro about the climate impact and the ecosystem restoration impact of water. Now you're going to learn about the global picture for how climate can be restored, ecosystems can be restored by restoring water to the landscape, and the specific science behind it. They're gathering decades of experience restoring water to landscapes and being able to track the climate impact of it. What they're about to show is going to blow your mind. It's going to inspire you, and it's going to want to make you take action, and you'll be able to support them in their upcoming campaign that's going to launch very soon. So without further ado, I am profoundly proud and excited to introduce Vlado Yalchek, Director of Rain for Climate, Michael Kravchik, Co-Director of Rain for Climate, co-author of New Water Paradigm, and Jan Pokorny, co-author of New Water Paradigm. It's amazing to see you all here. Thank you so much.
All right. So first of all, just a short intro, just to complete the logistics. So in terms of the webinar, it is basically logically composed of 2 parts. The first one would be the actual webinar. So that would be myself walking you through the presentation. This is going to take somewhere between 40 to 60 minutes, depending on how that goes. And then we are very much looking forward to a Q&A session, and that's the time when Michal, Jan, and myself, we would be very happy to take any questions, should there be any. So that would be in terms of the call. And let me try to share my screen. Very quick check. Are you guys able to see the presentation in a presenter mode?
Vlad, you want me to switch it over to you?
Yes, please.
Okay, I will do that. So you will be the presenter now. Okay, I can see it. Can everyone else see Vlado's screen? Can we see all right, I can see the presentation right now.
Okay, are you able to see the website right now?
Yeah, looks like everybody can see the website. Yes,
okay.
Yes. Yep.
Sounds good. Sounds good. So thanks a lot for the introduction. Much appreciated, and we'd like to welcome everyone on the webinar. It is actually a great pleasure to speak in front of so many people. And first of all, as far as the content of the presentation, what we are going to do is actually we are going to start off with the energy and how the energy behaves and flows on our planet Earth. And this, whatever will be stated, will be partially supported by the scientific evidence. We are going to bring up also some controversial topics just to spice things up a little bit. And by connecting the dots, we are going to make our way to water and to basically to explain why water is so crucial in terms of the climate restoration. Good, so we are going to start off with the energy as promised. So first of all, as far as the sun goes and the amount of energy we are getting from the sun can be perceived as a very generous source of energy. We are getting the solar radiation intake of approximately 10 megawatts per hectare or 2.5 acres. Now, this is kind of difficult to imagine these numbers. So you can think of it as of having 2 blocks of a nuclear power plant radiating on a surface of 4 square miles or 10 square kilometers. This is something just to put things in perspective. So we are talking about huge amounts of energy that the sun is radiating onto our planet. And there are several different ways on how the distribution of the energy can behave. And here I will try to work with the highlighter for the first time. Okay, good. So we are going to start off with the well-saturated landscape. So if the landscape is saturated with water, good enough, then a large portion of the energy of the daily solar radiation input is going to be absorbed into the evapotranspiration. So we are talking a huge number, somewhere around 70 to 80% of that energy is going to be used just to vaporize water, literally. Then we have approximately 5 to 10% of so-called sensible heat. This is the heat that we can actually literally feel on our own skin. And then we do have some minor 5 to 10% loss in terms of the heat flux to the soil and the reflectance. Now, this is a crucial information because if we compare the distribution of the solar energy with the landscape that is dry, this is a very significant number. So what happens is, again, the energy loss is about the same on any type of landscape. But if the landscape does have very little water, then only around 10 to 20% of that water is going to be used to vaporize it. And the rest needs to go somewhere. And since it has nowhere to go, it's going to turn into so-called sensible heat. We are talking about the 60 to 70% of that energy intake. So if you think of it as that power plant and that amount of energy turns into heat, we are talking about significant amount of heat. Now, what happens afterwards is basically in accordance to the law of the conservation of energy. Again, on the well-saturated landscape, basically, since the water is being evaporated, it is basically literally cooling off the local environment, since the energy is being consumed on changing on the state of the water, and then the vapor actually goes upwards within the atmosphere. Now, in the higher levels of the atmosphere, it hits the dew point. And when the dew point is being hit and the water condensates, the energy is being released over there. And this is how the clouds and later on the rain is being formed. After this happens and the conditions are favorable, the rain comes back as a sort of cooling medium back onto the landscape, and the whole process occurs again. This is quite different to the dry landscape, because what happens is that the heat intake hits the landscape, and since it has nowhere to go, in terms of the law of the conservation of the energy, it just turns into the sensible heat. But since there is a medium missing that would take the heat somewhere else, it just remains in the lower level of the atmosphere. So what's happening is that the atmosphere or the troposphere is getting hotter and hotter as more and more energy stays in the lower parts of the atmosphere, and it does not get transferred to the upper levels of the energy because simply there is no means on how to do that. Now I'll be moving on to the next slide, but just a second, need to erase the drawings. Good. Now, to make such a statement, one should have a good evidence. So what we are looking at is actually the small town in Czech Republic where Jan is working. This is the town of Třeboň in Czech Republic, in south part of Czech Republic. And here on this picture, you see the landscape, the urban zone as we usually know it. Now, here on this landscape, I would like to bring your attention to three particular spots. First would be the rooftop over here. The second one would be the square all the way down. And the third one, just for sake of this webinar, please have a look on the trees, but not on the shady area, but on the upper part of the trees where it's obvious that the sun is shining up there. And this is how the picture looks like in the infrared camera. Okay, apparently I will need to, okay, good. So coming to those three spots, the rooftop is around 37 degrees Celsius, so it is somewhere around 90 degrees Fahrenheit. The square itself is even hotter. We are talking somewhere around 100 degrees Fahrenheit or 40 degrees Celsius. And have a look on the trees. The trees, regardless of whether there was direct sunlight or we are talking about the shade, it is less than 10 degrees. This can be explained by no other means than the evapotranspiration, which means that the trees, as such, they basically draw the water from the soil and groundwater, and they breathe it out, literally. And as it changes its state from liquid form to gaseous form, this is where the energy gets consumed, and this is how the trees, they manage to get to cool the surrounding areas. Now moving on to the next slide, we would like to invite you to a short visit to a city of Prague, a beautiful city in Central Europe. And again, here we are going to have a look at four particular spots. First one would be the city center. So we are talking about the heavily populated and with the dense architecture. Second one, which is worth mentioning, would be the biggest airport within Czech Republic over here. And luckily enough, near the city itself, there are also two foresty areas, if you would. So one would be the National Park Šarka over here, and the other one is a large forest on the right-hand side. And now I will flip to the bird's eye view and imagine that this imaginary bird would be able to see the infrared. So again, on these spots, well, you have a close look. I mean, with the yellow marker, it's not that visible, but still, the city center, apparently along with the airport, is literally cooking. We are talking about approximately 35 degrees Celsius or somewhere around 90 degrees Fahrenheit, whereas apparently the foresty areas are significantly cooler, on average around 20 Celsius or around 65 degrees Fahrenheit. And this has major implications to what's happening to our climate and actually to our urban zones as well. So let me erase the markings. And I'll be moving on to the next slide. And what's happening within the cities is that the cities actually do create this so-called umbrella of heat above them. This means that the inner part of the cities is significantly hotter than the outer part of the city. Now, this might not seem like much, but a difference of a couple of degrees, be it Celsius or Fahrenheit, it does not really matter, does make a huge difference in terms of the flow of energy and the flow of the air eventually. Just for your imagination, if you think of one of the highest cities in terms of the density, the Tokyo, this difference would be 10 degrees, which is massive. And moving on to the next slide, the impact that this fact has on the local weather and the local climate and cumulatively on the global climate is actually very important, because The cities, they basically literally radiate the heat, and the overheated areas, they basically exchange the heat with the surroundings. And what's happening is that the cities, they are pushing the actual air, which is cooler and more humid, out from the local presence. So it's being pushed to the cooler regions, and the consequence to that is that there is significantly higher rainfall in the cooler areas, whereas on the cities, there is much less rain than one would expect. Okay, now moving on to the next slide, we are going to have a look on the actual water cycle. So everybody is more or less familiar with the big water cycle. Now this is basically the exchange of water between the oceans and the continents. So everybody is aware of that. But what is most important is that there are also these so-called small water cycles. Now the small water cycles, so this is basically, you can think of it as a closed cycle of a water which is being evaporated from the region, and then it falls back more or less as in a form of precipitation on the very same region. Now, and this is basically each of those cycles, you can think of it as a small and very efficient AC unit. So it is basically literally transporting the sensible heat from the lower areas, and it is transporting it to the upper areas of the atmosphere, and such effectively it is A, cooling the actual troposphere locally, and B, it is actually transporting the energy upwards where it is being radiated to the outer space. If the energy remains within the troposphere, it's going to cause turbulent phenomena such as tornado and so on and so on. Now the problem is that with the urbanized zone or the industrialized agriculture, is that there is a significant runoff in terms of the precipitation, and there is very small groundwater recharge. And all of the water that is being lost in terms of the runoff is actually missing somewhere. And the somewhere is the actual small water cycle. So the more water we are going to lose in terms of the runoff, the less efficient that local small water cycle is. And the less efficient it is, the less energy it is able to transport to the outer layers of the atmosphere, and the more sensible heat remains in the surrounding troposphere. Now let's have a look on what was just told as a run chart in time. So basically, as we have this runoff and this old paradigm style architecture, there is, over the time, there is lesser and lesser evaporation and infiltration in terms of the water. Now, what this happens is that locally, apparently, there is also precipitation, which is basically diminishing over time. And the consequence to that is that over the time, the small water cycle is getting weaker and weaker and weaker as the water is being drawn somewhere else. The consequence to that is that there is significantly larger amount of energy which remains in the troposphere. The amount is increasing, and it is increasing up to the point that the turbulent phenomena will start to occur more and more frequently. Now, moving on to the real life from the graph, what we are looking at is actually one of those turbulent phenomena, which is the heavy rain. I mean, the heavy rain as such is basically nothing else but a high density cold or cooler clouds with huge humidity, and these are pushed or clogged together because they have no means on how to disperse on the larger area. And what happens is that in this fashion, you are going to get heavy rain on a small area in huge amounts. And on the rain actually then drops on the landscape, but the actual landscape nowadays looks like this. So as we started to industrialize the agriculture, what's happening is that we are massively deforesting the landscape. hand in hand with that, there's massive erosion on the landscape. By the way, we are going to see this picture one more time tonight at a different occasion. In terms of the industrialized agriculture, we managed to get to the point when there is a constant surface discharge of water whenever it rains. And on top of that, we are actually putting 57,000 square kilometers or 22,000 square miles of land surface under a roof. If you connect the dots, then what's happening is, for example, only those 57,000 kilometers of asphalt, they create so much radiation and so much heat in terms of the sensible heat in the troposphere that it is unbelievable. And the consequence to that is what we are currently experiencing worldwide. First of all, the landscape, as we shown previously, is not necessarily capable of holding much of the water that falls there. And once we get the heavy rain, the flooding is almost imminent. And with such heavy floods, we are losing also soil. We are losing sediment. We are losing all of the essential parts of the soil. And eventually, what's happening is that the desertification takes place, and we are going to turn the landscape efficiently into semi-desert or desert. Now, related to that is that apparently it's very difficult to live in these areas. So associated with the desertification, there is the immigration of people. So we are talking about large quantities of people moving to different areas. And when you have these climate change immigrants, as we call them, these people move around and they destabilize the local economies. And once the economy gets destabilized, the whole system falls apart. Now, today we would like to focus mainly on the US because we do have a good data set on the US. So this picture actually shows the primeval forests as they used to be and as they are as of today on the continental US. Now, as you can see, apparently in the 60-20s, half of the continent was actually half the forest, the primeval forest. We are specifically talking about the primeval forest due to the fact that this is a very efficient ecosystem in terms of the small water cycle. And apparently, as the forests were diminishing, they were replaced by industrialized agricultural land, urban zones, and also managed forests. But the managed forests, the human managed forests, are different to primeval forests. And it is quite common then managed forests do lack water as well. And consequence to that is that now we are going to have a look on the actual real life scenario of the superstorm Sandy. So this is what the continental US inland looks like, and it is quite common. And once this type of land receives heavy rain, it's not able to absorb it. So once there will get heavy precipitation, it is almost constantly underwater. And this is how it looks like when the Sandy did touch the continental US. Now, this happened in 2012 in October timeframe, and this was actually prior to the record drought in the US. And this is the drought monitor from August the 12th. But apparently, whatever date you would choose around this year, the map would be more or less the same. So you can think of it actually as sort of a heat map as well. So we are not looking at the drought only, but the darker it is, the more sensible heat there is, and the more energy there is being absorbed within the local troposphere. And hold and behold, this is where the superstorm Sandy landed. And it suggests that the superstorm and the cool and humid air was not able to get inland due to the fact that there was sort of, you can think of the sensible heat as sort of a radiation upwards, within the troposphere, which is pushing the cooler air out towards the edges of the continent. And this is how it looks like, what happened with Sandy. And Sandy, as many of the hurricanes, is being born just by Africa, by the coast of Africa. And as they travel, they basically get the strength, and then they are within the Gulf of Mexico or around the continental US. They are basically taking the curve in this fashion. Now, this would be a little bit sort of speculation, not necessarily a proven fact, but I'll leave it up to your imagination. Now, imagine that on the continental US, we still would have the primeval forests, or we would have other ecosystems that would function as primeval forests and would have still working small water cycle. And imagine that we would be able to get the Africa, or at least part of the Africa, the coastal part, green. Now, I wonder a little bit, what would this map look like, and what would the damage look like in terms of the hurricanes? And one more map to look at. Now, this, in terms of the coloring and the placement of the dense areas, might look familiar, but this is actually a different map. What we are looking at is the occurrence of tornadoes. And again, if we state that continents as such, when they are overheated, they are capable to create the turbulent events and phenomena. And on the other hand, we have a look on the objectively measured occurrence of the tornadoes. Again, this logic suggests that there is a close connection between the occurrence of tornadoes and the amount of sensible heat present in the troposphere. So that would be the basic information in terms of the hurricanes. And now we are moving on to California and the situation in California. Excuse me. So this is how California looked like earlier, back in the days, when the small water cycle was still saturated. So most likely at minimum part of the country was well saturated with water. So the small water cycle was actually taking place effectively, and there was an exchange of heat, an exchange of humid air between the ocean and the continent. And this is how California looks like nowadays, particularly in summer. So what's happening is, due to the industrialized agriculture and the urban zones that are quite heavy in California, the water cycle is being emptied. And actually there is barely any left in terms of the water. And what's happening is that the colossal amount of energy that is being radiated upwards is actually pushing the humid air from the ocean outside. So it's not letting the humid and cooler air in because of the pressure. And this is closely related also to the wildfires and the winds and wind gusts that are actually supporting the wildfires. I mean, apparently, if you have a bare bone dry country, it's enough to have one spark, and the wildfire is a never stopping event. And this is how California functions in terms of the winter time. So the energy intake is slightly lower. Therefore, the overall energy that is being radiated upwards is actually smaller. And on the areas where the energy is low enough, it lets the cooler air from the ocean in. But again, since this is actually this is turbulent event, what's happening is that a significant amount of clouds get inland. Again, on one area, the heavy rain takes place, and once the heavy rain falls down on the soil, the soil as such is damaged and is completely dry. There is nothing to hold it together. So the soil literally turns into mud, and if the conditions are favorable, there is not a problem for a mudslide to happen. Also, with the heavy rain, the water is actually pouring over the top of the soil because it is barely absorbing any. So the floods are quite common and easily to be explained. And now let's have a look on California again on the run chart in terms of the time. So we are somewhere around here. So you can see that the water in terms of the precipitation and the infiltration had been and the total amount of energy that is being left within the system is increasing as it is causing these turbulent events. Now the question is, how do we get out of it? And the answer is, there is a need to initiate a national rainwater retention program. And when I say national, it is not necessarily referring to the fact that this program should be managed and initiated by the government. I'm talking about the magnitude of such movement. And if we happen to have the spark and get the movement going, then what will happen is that we are going to create sufficient amount of water retention measures. The water that gets into the gets in onto the continent gets captured, and the continent gets stabilized thermally, and eventually the small water cycle will start healing. The more and more water will be captured, and the more water is captured, again, the amount of energy that is left in there in terms of the sensible heat is diminishing, and the weather and the climate is getting stabilized. So now it's probably the best time to have a look on the old water paradigm versus the new water paradigm. So what we are looking at would be actually two schemas of the two. So first of all, and most important, in terms of the water as a source and a reserve, the old water paradigm perceives the surface water to be the precious one. So you can think of it as these huge dams that are being built. Whereas the new water paradigm states that it is the rainwater, and actually the rainwater within the ecosystems that is both the source and the reserve. This is absolutely crucial, the statement within the ecosystems. So it is not about capturing the rainwater only. It is about putting it back to the ecosystem to have it at work. Now the second one, the second difference would be the rainwater, where the rainwater is perceived as inconvenience, so we just need to get rid of it quickly. Whereas in the new water paradigm, we want the rainwater to be retained, and we want it to enter the local ecosystems. Also, there's a statement that the sealed soil has barely any impact onto the climate change. And when I refer to the previous slides, it is just the opposite. We just shown that the sealed soil, at minimum, has the potential to release colossal amounts of energy within the troposphere. So this suggests that it has very much to do with the global warming, or we translate this into that it has very much to do with the extreme weather events. And in terms of the responsibility, everybody's pointing fingers at the water experts on the rainwater, on the old water paradigm, due to the fact that not everybody can build a dam. But in the new water paradigm, basically anybody can get involved with the rainwater measures. And that's why we are getting the communities involved. And that's why in terms of the groundwater recharge, this is significant as opposed to the old water paradigm. The evapotranspiration again is significant against the old water paradigm where there is barely any, and the runoff. Our goal is not to have any or very little, whereas in the old paradigm, everything is being channeled away from the area where the rain falls. Now, so basically the key is the rainwater retention. And what does it mean in terms of definitions, if you would? We basically want to leave the rainwater where it falls, or as close to the area where it falls as possible, in terms of and allow it to enter the ecosystems and to restore life. And there are also some ethical responsibilities and principles that one should follow. So first of all, this solidarity means that only the water retention measures that are implemented should not worsen the situation upstream or downstream within the watershed where they are implemented. This is absolutely crucial. It's not a good thing to solve your own problem and just move it onto your neighbor. Second one, in terms of the partnership, all of the involved parties need to be discussed. So here we are talking about the forest rangers. Here we are talking about the landowners. We are talking about officials. We are talking about administrators. Anybody needs to be brought behind one round table before the water retention measures are being designed. The natural processes should be basically resurrected or supported by the rainwater retention. This means that basically the local biosphere should be supported and should benefit from having the rainwater in place. In terms of the subsidiarity, we want to aim on having this rainwater done on as level and on as low level as possible in terms of the governmental structures, because it is the local communities and the local governments that know the best their environment, their specifics. And in terms of sustainability, if we are going to proceed further, then we are actually creating the future for our children. Moving on to the actual rainwater measures and the actual implementations, if you would. So this is how some of the rainwater measures look like, and these are specifically designed for the landscape. Excuse me. This is just a small flavor, if you would, from a catalog of over 5,000 types of different rainwater retention measures. And you can do rainwater measures not only within the landscape, but also within the urban zones. The whole logic is to cut the pipe literally between the rooftop where the water is being harvested and the nearest creek, and have the water to sink in and work with it. And what you can do and what you can achieve is epic. This is how a healthy urban zone could look like. So the quality of life is getting higher. The area in terms of the energy flow is functioning well. It looks nice. All the benefits in the local ecosystems, they are actually, you can think of these as a local ecosystems with a life on their own. And so when the water retention measures are implemented on the landscape and they are designed well, they are able to achieve almost something that is difficult to imagine, which is rain restoration. So when we do have, for example, a landscape similar to this, where you have a mountain chain and there is a desert area behind, and you design the rainwater measures well enough to capture some of it, what happens is that the water gets captured. It evaporates, it creates the local clouds, which shade the local area, it cools off the area, and it creates the possibilities for the rain to come in more and more towards the inland, and you can turn the semi-desert or desert into green area. Now moving on to the real life implementations and something that we have experienced on our own skin. So in 2010, there was the Landscape Revitalization and Integrated River Basin Management Program, as we call it. This was basically a national program in Slovakia. It created one of the first national rainwater or water in general policies. It was designed for 10 years, and within the first year and a half of the execution, we have invested 42 million euros, so it's more or less identical in dollars. 100,000 different water retention measures was implemented, and around 10 million cubic meters of water is being restored annually and being put back to the small water cycle out of the planned 250 million. Now the work was done in 488 different communities, and approximately 8,000 seasonal jobs were created, particularly for the people who had difficulties to find the job. And when we did ask after this year and a half to locals, the evaluation by the village representatives was amazing. And actually here I'm going to show you, this is, bear with me a second. This is our website, the Rain4 Climate website. And if you go to the section Science Behind, this is where you find quite interesting information. And some of this information is also the proof of concept locations where this actually does work. The first one that is being listed there currently is the Slovak National Program. And here I'm going to show you a couple of pictures how it looked like when the program was run. So these are the water retention measures that are being built within the landscape. Now, all of the materials, as you may notice, is the local material. So there is no need to pay the extra cost in terms of the economy and also in terms of, for example, the carbon dioxide emissions on having some specific material imported. This is all of the local materials that are being used and that are being implemented directly into the ecosystem. And this is how it looks like when implemented. By the way, all of these water retention measures, it was 10 years ago. They are still functioning. Michael has new pictures, which he brought up recently. They are still working just fine. And you can distinguish between the soft ones and the hard ones, where the soft ones are the ones that don't require concrete to be poured in. So this is a small taste of what they look like. Now also the heavy machinery is being used in some of the areas where necessary. And this is how it looks like in the open landscape. And these are the hard ones. So these do require the construction effort. So this is just a small taste of what it looked like of this Slovak National Program. Now I'm flipping back to the presentation, and this is a small example of a side effect, if you would, of the water retention measures. So the bottle here on the right-hand side was actually picked from the creek that you can see running over here on the right-hand side, and the clear bottle, I mean the clear content bottle, was picked from the dam you are looking at. So you can see the amount of sediment that is being actually captured by the rainwater measure as a side effect. So this is not only capturing the rainwater, it also helps to prevent erosion and loss of soil. And then, interestingly enough, the program got stopped. Now, one might ask, why is that? So basically, the situation as it was at that time in Slovakia was that we did have a destabilized government, a new general election took place, a new political party won, and their decision was to stop the program. Regardless of the fact that the program brings benefits to everybody, regardless of your skin color, your political views, or your gender, or your geographical area. Nevertheless, one political decision was enough to stop an amazing piece of work. And here is why the Rain for Climate. So I'm going to flip back to the Rain for Climate website and talk a little bit and flip it back and forth about the Rain for Climate. So the Rain for Climate is actually a rebranded new water paradigm. And the goal of Rain for Climate is to bring the new water paradigm to ordinary people who don't necessarily get involved in terms of revitalization and so on and so on. So that's why precisely this is what we stand for, Rain for Climate. And the slogan, Restore Your Weather, we are stepping away from the intangible concept of climate change, which almost no one can do anything about, but everybody is familiar with the weather, and particularly with extreme weather. Almost anybody had experienced some. So hence the Rain for Climate, Restore Your Weather. So our goal is actually to become an umbrella program, and particularly for communication outside. We are talking about different people. We are talking about different communities. We are talking about different countries. We are talking about the communication in a global, international one. This should be also an umbrella program in terms of the campaigning, because united we stand, the more we are going to achieve. I mean, it doesn't do any good if company A calls this ABC, let's say in Americas, and a company B calls it XYZ in Europe, because the people's attention just gets distorted and they get confused. Our goal is to unite and make this a big international movement where we are working and pulling one direction. The second goal would be the center of excellence. So our goal is to cooperate globally, and also to be sort of the data repository of the valid information. Now, what happened is previously when Michal and his colleagues, they have released the book Water for Restoring of the Climate, people started to sort of cherry pick on the knowledge, and they started to call it their own names. They started to implement it partially, successfully, not to full extent here and there. And this is what we don't want to do, because it hurts the concept. When someone implements this not the right way and it stops functioning in a couple of years, it does not do any good for the philosophy and the whole thing behind. So that's why our goal is actually to deliver the quality that is so that this, in terms of the rainwater measures, is functional. It does stabilize the weather. It does help the floods and erosion efficiently enough. And also in terms of the data repository, in the science behind section, to which I brought you already earlier, you can find anything over here, and this is for you to use. You can find the rainwater paradigm book. You can find the different movies over here. You can find the scientific publications which are supporting whatever is being said right now. You can find the proof of concept locations. Actually, with our partners currently, we do have at minimum one project on every continent where there is a human being living permanently. We are actually processing it over here. I still have 3 of the projects in my inbox that I haven't had a chance to process yet. And we are going to upload them over here so that this would basically support whatever we state, and that this is not only theory, but it is working in real life. And last but not least, the grassroots movement. This is sort of a buzzword, but this is very closely associated with the Slovak national program that we did talk about earlier. Our goal is to work with individuals and start from the bottom up, and to work with people and to work with the landowners to create the sufficient buzz and to create the sufficient attractiveness of the concept, and to shift this to mainstream. And once this will become mainstream, the politics will follow. The Rain for Climate, there's actually a couple more concepts to it. The fact that we are able to measure the results, the fact that we are using absolutely novel models in terms of the processes and the disruptive model on how everything will work and how we want to achieve this long-term sustainable. Due to the time constraints, we are not going to discuss this further right now. But this is just to let you know that these three will be discussed in greater detail in reference again to real life examples on the webinar number 2. And now, where are we with the Rain for Climate? Now I'm going back to the Rain for Climate website, and on the milestone section, you are going to find again everything that was ever done and what is being planned to be done over here. So we are moving down from the 80s, we are moving through the feasibility study, and we are entering the global rollout phase. So Michael was actually touring the US last year. We initiated the Rain for Climate, which you are looking at as we speak. So the first of the webinar right now is already part of the global campaign launch that we did. What is there to follow is that we are going to be running a crowdfunding campaign probably towards the end of April, early May. Also, the new version of the New Water Paradigm book would be coming up shortly, collecting points of views of different authors and the years of experience gained. We are going to create an exciting Rehydration Global portal. And all of this is being published, again, for anybody's view, so that people know what is it we are doing, people know what our goal is, and this thing is fully transparent. Now, in terms of the experts, currently on the team section, there's quite a few people already involved in here. So this is the core team, out of which you are looking at two people right now. The advisory board. This would be, for example, Rajendra Singh had accepted the invite recently, I believe about 2 weeks ago. More people are coming in. So these are the experts from, at this point, 8 different countries. These are the top-notch experts who are working and associated with the field. The resources on the Science Behind section is being put together as we speak. The global campaign is launched. And here I'm actually about to close the webinar with a statement, what can you or your friends do for the moment? You know, as every moment, we are heavily dependent on people and on effective communication. So for the moment, if you wish so, and if whatever was told does make sense to you, please do follow up on the social media, sign up for the newsletter, use the contact form, get in touch with us by any means, spread the word. And please support us on the crowdfunding campaign once we are going to launch it, and we take it from there. Well, and I thank you very much for the moment and the time that you spent with me, and Raleigh, I guess I'm giving you the word back.